Hello, pre-algebra students. Mrs. Tremblay, it's time for lesson 10A.1, solving equations with variables on both sides. So with these equations, you're going to see the variable appear twice, one on either side of the equal sign. And they're not too tricky to solve. Basically, the only step we're going to add is we need to cancel out one of the variable terms, and then you're going to end up with an equation that looks just like the ones we've been solving, 1 steps and 2 steps. So the steps are all listed out in here. We did a little discovery in class as to why it's going to work. So let's go through some of these examples together. In step 1, we're always going to keep change. Then we're going to add the opposite of one of the variable terms to both sides of the equation, because adding the opposite of something is what allows you to cancel it out. And you can't solve when you have the same variable term twice. You have to have just one of it, so we need to simplify it, and that's how you do it. Then basically, you're going to add the opposite of the number being added to the remaining variable term, and multiply or divide to isolate the variable, and of course we can always check using substitution. So let me zoom in a little bit here. Alright, with this first one, draw my line down. There's no subtraction to keep change, but I see I have 3h on this side of the equal sign and negative 2h on this side of the equal sign. Now, our step number 2 says add the opposite of one of the variable terms. So I want you to think about which one you'd like to cancel out. If you cancel out this 3h, it looks like we're going to end up with a 1-step equation. And if you cancel out the negative 2h, it looks like we're going to end up with a 2-step. I don't know about you, but I'd rather do a 1-step. I'm kind of clumsy. So we're going to get rid of this 3h. And to get rid of the 3h, you don't divide by 3. That's how you would get h by itself. When you want to completely cancel out 3h, we need to add the opposite of it. And whenever you do to one side, you have to do to the other. So 3h plus negative 3h is 0. 0 plus 10 is 10. And negative 2h plus negative 3h is negative 5h. So right now, nope, we're not done, but we do have a nice little 1-step instead. So to finish solving this out, now I need to divide by negative 5 because it's being multiplied currently. If you divide this side by negative 5, you get 1h, which is h, and if you divide this side by negative 5, you get negative 2. Now that h is by itself, we have solved it. That's it. Now when you go to check these, and I'm not going to end up showing you the check for every single one, but when you check this, you actually have to plug the variable in twice because it appears twice. So in this original equation, 3 times negative 2 plus 10 is supposed to equal whatever negative 2 times h was, which was a negative 2. So basically I plug this negative 2 in for that h, and this negative 2 in for that h, and you want to make sure that one side equals the other. So you're solving both sides separately. So if you look at the left, 3 times negative 2 is negative 6, and negative 6 plus 10 is 4. And over here, negative 2 times negative 2 is 4. So at the end, when you get one side equaling the other side, that means the solution that you found is true. So again, when you're doing the check, you plug it into each side separately and make sure that you get the same resulting amount. All right, moving right along. Draw your line. And again, I see that I have a negative 4h on the left and I have this y on the right. So whenever you have a variable on each side, we need to choose one of them to cancel out. It's a little bit easier to understand how to cancel out this y when you put a 1 in front of it before you add the opposite. We'll remember that from our algebra blocks. So this really means 9 plus negative 1y. Again, I want to think about which one to cancel out. It doesn't matter which one, it's just sometimes it makes it a little bit easier if you choose a certain one. Like for example, if you chose to cancel out negative 4y, you're going to end up with a 2-step. If you choose to cancel out negative 1y, you're going to end up with a 1-step. So again, let's go with the 1-step. So we're going to cancel out this negative 1y. You cancel out a negative 1y by adding a positive 1y. Negative 4y and 1y are like terms, so we can add them. Negative 4y plus 1y is negative 3y. Those are gone. 9 is left. Now we just have this itty-bitty little 1-step to solve. So we're going to go ahead and divide by negative 3, because that's how you get rid of a negative 3 when it's being multiplied. And you get y equals negative 3, because 9 divided by negative 3 is negative 3. To do a check on this, you would just take negative 4 times negative 3, that's 12. And when you take 9 minus negative 3, that will become 9 plus positive 3. which is also 12. And 12 does equal 12. Last time I checked, it did. So we're good. All right, last one on the top row, draw your line. And again, if I chose to cancel out this negative 5x, I'm going to be adding 5x over here, so I'll have a 2-step. But if you choose to cancel out this regular x, you're going to get a 1-step, so let's get the 1-step. Again, this means we have 1x. To cancel out 1x, we're going to add a negative 1x. And negative 5x plus negative 1x is negative 6x. And we have 12 left on that side. So here's our little 1-step. Go ahead and divide by negative 6. And x equals negative 2. And again, one more time, just how to check it. If x is negative 2, then negative 5 times negative 2 should equal negative 2 plus 12. So I'm plugging in what x is to each side, and then you would just solve it. So negative 5 times negative 2 is 10. Negative 2 plus 12 is 10. And 10 equals 10. So that's how you'd know that you were right. Okay, in the next row here, instead of there being one variable term and then a variable term and a constant, this time we have a variable term on each side and we have a constant on each side. Those constants are the ones that don't have the letters next to them. And now you're really going to see it doesn't matter which one you cancel out. It doesn't matter which one you get rid of. So start off, keep change, change. I'm going to put a 1 in front of that y so I lessen the confusion. And you're going to pick which variable term to cancel out. Don't start trying to move the constants around, then you end up just moving them back and forth forever and ever. Choose the variable term to cancel out first when you see that it appears on both sides. Alright, so with this one, it doesn't really matter, but I think I'm going to cancel out 1y. To cancel out 1y, I would add a negative 1y to each side. Now when we're trying to figure out this side here, we learned about like terms at the beginning of this chapter, right? Only the y's can go together. So this 15 is just going to stay the same. And negative 4y plus negative 1y is negative 5y. Those y's are gone. And we keep changes. Remember, it was minus 8. That means this is a negative 8. Now instead of having a 1-step, we have a 2-step. That's all right. We know how to do those. With the 2 steps, your first step is to get that variable term by itself. So we want to get rid of this 15. And to do that, we would add a negative 15. That allows you to cancel it out. So negative 5y is left over here. And on this side, negative 8 plus negative 15 is negative 23. Now we have our little 1-step. And remember, to solve 1-steps that are multiplication equations, you just divide by the coefficient. So negative 5 divided by negative 5 is 1. 1y is y. And when you take a negative 23 divided by a negative 5, you get a positive 4.6. Decimals are allowed. Don't be frightened of them. Again, to check it, I would honestly just use my calculator and type in 15 plus negative 4 times 4.6 and hit enter. And I would type in 4.6 plus negative 8 and hit enter and make sure they match. And they do, because this is like the millionth time I've done this problem. You try checking it on your own. I'm sure it'll be fine, and if you're not sure how to check it, just ask Mr. Terry or myself, and we'll show you how so that you can get 100% on your next quiz. Alright, draw your line, change your signs. Poet, and I didn't know it. Actually, I did know. I did know I was going to say that. Yep. Okay, in this next one, I have a 4b. I have a 6b. Last time I canceled out the variable that was on the right. This time, let's cancel out the one that's on the left, just so you can see it doesn't really matter. To cancel out this 4b, you guessed it, you're just going to add a negative 4b to each side. Because 4b plus negative 4b are 0, and 0 plus negative 2 is negative 2. 6b plus negative 4b is 2b, and I still have that negative 4 left because it's not a like term. It can't go with the b's. It's all by itself. Alright, now I want 2b by itself, so I'm going to get rid of this negative 4 by adding a positive 4. Negative 2 plus 4 is 2, and 2b is left on this side. Now to get rid of this 2 that's being multiplied by the b, we're just going to divide by 2. And 2 divided by 2 is 1, and 1b is b, and 2 divided by 2 is 1 again. So 1 equals b. And again, if you wanted to do kind of a mental quick check, if b is 1, 4 times 1 is 4, plus negative 2 is 2. 6 times 1 is 6, plus negative 4 is 2. And 2 equals 2. So that means that b is 1 is correct. Alright, next one, draw your line. And again, I think it's helpful if you put a 1 in front of the variable when it doesn't have a number. And I'm going to keep change that. So this is really 9 plus negative 1n equals 1n plus 5. Alright, so let's cancel out this negative 1n. If you want to cancel out the positive 1n, it'd be okay, but I'm going to choose to cancel out the negative 1n. And to cancel out a negative 1n, you'd add a positive 1n. And whatever you do to one side, you have to do to the other. Alright, so negative 1n and n, gone. 9 is left. 1n plus another 1n is 2n, and I still have plus 5 added on at the end because it doesn't have an n. It doesn't combine. Alright, now it's a two-step. I want 2n by itself, so we're going to add a negative 5 so that that 5 can go away. 9 plus negative 5 is 4, and when you add those, they're gone. 2n is left. We're going to divide by 2 to get rid of this 2 in front of the n, the coefficient, and you get n is 2. Now, if you look directly underneath this example, it's the same exact problem. What I'd like to do is I'd like to actually go down and do this one next and show you that it really doesn't matter which one you choose to cancel out. So in this equation here, we canceled out the negative 1n, right? This time, we're going to cancel out the positive 1n. So again, go straight down. I'm still going to do my 1 coefficients here. And instead of canceling out the negative 1n, we're going to cancel out the positive 1n. So to cancel out this positive 1n, I need to add a negative 1n to each side. On this side, the 1n and the negative 1n cancel and 5 is left. And over here, we still have this 9 all by itself because it doesn't have an n. And you have a negative 1n and another negative 1n. That makes negative 2n. Now, right now, our equation does not look like the one above it. It's okay. Our solution is going to look like that. I promise. Okay, so this is a two-step. I want negative 2n by itself this time, so I'm going to add a negative 9 so that those 9's cancel out and negative 2n is alone. 5 plus negative 9 is negative 4. Now I'm at the one-step point. I get to divide by negative 2 now, and n is positive 2. Now if you look at the previous example, do you see how 2 equals n? And in this one, n equals 2. It doesn't matter which variable term you cancel out. You'll get the same solution at the end. As you're solving the equation, it'll look a little bit different, but if one side equals the other, if it truly does, then it's not going to make a difference. So as you're solving it, your problems might look different than the person sitting next to you. When we put our answer key up on the board for you to check your work, you may have solved it a different way. You should still get the same answer no matter what, though. Okay, now we'll go back to the order where we were at. We're doing the 4y one down in the left side corner. Draw your line. Okay, again, pick either the 4y or the 3y to cancel out. I'm going to cancel out this 3y because I know that 4 plus negative 3 is 1y, and then I already have the y by itself. You can do whatever you'd like. Alright, so adding a negative 3y will get rid of that. And like I said, 4y plus negative 3y is 1y, or just a plain old y. And I still have this 6 being added, and that equals 17. Next step, I want y by itself. So I would add a negative 6, because to undo things that are being added, you add the opposite, or you subtract. Same thing, because subtracting 6 and adding negative 6 is the same thing. Alright, 17 plus negative 6 gives you a positive 11. 4 times 11 is 44, plus 6 is 50. 3 times 11 is 33, plus 17 is 50. So we know that we're right. Last one of these, and then we have some perimeter ones. Draw our line. Change your signs, and again, choose one of them to cancel out. This time, I think I'm going to cancel out the negative 2x. Why not? To cancel out a negative 2x, because that was a subtraction problem to start, that means that 2x is negative, I need to add a positive 2x. So those are gone. Negative 7x plus 2x is negative 5x, and I still have plus negative 5 left there. Now, it's just a little two-stepper. I need to get rid of this negative 5 that's being added to the negative 5x. To do that, you add a positive 5. 15 plus 5 is 20, and those are gone, so negative 5x is what's left. Now it's a multiplication one step. To undo that, I'm going to divide by negative 5. Remember, don't change signs. I want to divide this number by itself to get 1, because 1x is the same as x. And 20 divided by negative 5 is a negative 4. So again, basically with these, all you do is add the opposites of one of the variable terms on either side of the equation, And then you're going to be left with a 1-step or a 2-step to solve. All right, turn your page. I want to show you what the application problems look like for these. All right, so shapes, a little bit of geometry connection here. It says in the directions here that in a regular polygon, each side has the same length, and I ask you to find the perimeter of each regular polygon. So basically what I'm telling you is that these two shapes I have on here are regular polygons, meaning every single side has the same length. So whatever this side length is, this one's the same, and so is that. Whatever this little side length is, so is this, so is this, so is this, so is this, and so is that. So regular polygons. Now I'm not actually asking you to find out what x is, I'm asking you to find the perimeter. To find the perimeter, basically you just have to add up the length of all the sides, right? So in order to know the perimeter of this, I need to know what one of these side lengths is. And I do give you enough information. It might seem like there's not, but there really is. Because if we know that this is a regular polygon, and that this side length equals this side length, if I know this equals this, I can set up an equation to solve for x. Because if this side equals this side, then doesn't negative 4x plus 9 equal 5 minus 2x? Yes. Now, if you wrote 5 minus 2x equals negative 4x plus 9, that's okay. It's like when we solve for x and we get negative 4 equals x or x equals negative 4. It doesn't make a difference what side it's on. So if you wanted to write this the other way around, you could. From here, we can go ahead and we can solve to find out what x is. So let's do that. Draw your line, change your signs. Choose one of the variable terms to get rid of. This time I think I'm going to get rid of negative 2x by adding a positive 2x. It wouldn't matter in the whole scheme of things if you chose the other one. Negative 4x plus 2x is negative 2x. I still have plus 9. Those are gone and 5 is left. Now I'm at the 2-step spot. So to solve this 2-step, I need to get rid of this 9. So I'm going to add a negative 9 to each side. Those are gone. Now I'm left with negative 2x equals negative 4. Now I have a 1-step. Divide by negative 2, and I get x equals 2. And this is the part where everybody says, okay, I'm done, x equals 2. You're not done yet. You're not done because I don't ask you the value of x. I ask you what the perimeter is. And then people will say, okay, Mrs. Tremblay, the perimeter is 2, 4, 6. It's not 6. If x equals 2, then to figure out what one of those side lengths is, I have to plug it in. And you can plug it into either one, because either one will give you the same answer because this side equals this side. But if x equals 2, that means that 5 minus 2 times 2 is how I get that side length. In other words, 5 minus 4 because of order of operations, or plus negative 4, however you look at it. So the moral of the story, this side length is 1. If you would have chosen this expression, you would have had negative 4 times 2, which is negative 8, and negative 8 plus 9, you guessed it, is also 1. So because those are equivalent, it doesn't matter which one you plug the value of x into, they're both going to give you the same. So if x equals 1, if x equals 2, that means this side length equals 1, this side length equals 1, and you can guess that this side length also equals 1 because it's a regular polygon. So that means the perimeter is 1 plus 1 plus 1, or 1 times 3, which gives you a final answer of 3. So your actual final answer for this is 3. Quite a few steps, but I need to make sure that when you see a problem like this, you know what they're asking you to do. Usually the steps are outlined for you. You have to logically think through it. Pardon me. All right. So next one, same kind of thing, except right now we're dealing with a 1, 2, 3, 4, 5, 6-sided figure called a hexagon. All right. So if this is a regular polygon, that means that 4x minus 5 is equal to 7 minus 2x. This is the same kind of problem here. All right. So we want to find out what x is first. So I'm going to keep change, and I'm going to get rid of negative 2x. I'm going to get rid of negative 2x by adding a positive 2x. So that leaves me with 6x plus negative 5 equals 7. Just a regular little 2-step now. I want 6x by itself, so we're going to add 5 to each side. 6x would equal 12, so those 5's are gone. Divide by your 6 because it's being multiplied, and 12 divided by 6 is 2. So again, x equals 2 is not my answer. X equals 2 tells me what to plug into this side length. So you can plug it into either one. I'm going to choose this one here. So So 7 minus 2 times 2 will give me that side length right there. Or 7 plus negative 2 times 2. So 7 plus negative 4 is 3. Again, order of operations says you need to multiply those first. So that means that this side length here is 3. And if this is a regular polygon, then that means all 6 sides are 3. So to find the perimeter, you can take 3 and add it 6 times, or you can just do 3 times 6. Your final answer for that is 18. All right, you're done.